Hi again. I wanted to show you this thing. This is the Telequipment Oscilloscope D32, and it's an English-made piece of equipment, circa 1972, I think it is. And it's a 2-channel scope that there's the other trace there, runs on line power, which it's doing right now, or look inside here, you can see it's got some very old crusty NiCad batteries, 6 D-cell NiCads, which have leaked in it and need replacing. But this thing has been sitting around my shop for a lot of years. It got pushed off into the corner and forgotten about. I used to use it years and years ago when working with switching power supplies and the hot sides of equipment like that needed isolation. This thing, being battery powered, was ideal for that. Anyway, and it's still, I had to do a little work on it to get it to power up and give me a trace again. Quality control on these things was not great to begin with. Neat devices though they are. Well, it's really old for one. And they are known for poor solder joints. Dry solder joints is what the manual calls them, and maybe it's a British thing, dry solder joints. But as you can see, it's all analog, discrete components. There's not a single integrated circuit in this thing. So let's have a look at it and just see what it's like inside. It's pretty cool because these side bits swing out like this, so you can get it. See, I'm going to short it out with all this junk on my bench here. It's got it's really quite serviceable. You can get to the battery pack that way. You can get to the back side of all the boards and all the wiring. There's your time-based switch. The other side flips out like that too. It might be screwed down. Oh well. It will also swing out like that, so you can get to the innards of it and service the thing. Or do calibration or whatever you intend to do with it. Probably replace the batteries is the first thing I should do. But after getting it to power up and give me a trace like this, I found that it will not trigger. Something is wrong with the trigger circuit. I can, I got it to sweep, and I can get it to give me some kind of waveform, but if I set it to normal trigger mode, the trace goes away like you'd expect, but nothing. Put it back to auto, I get my trace back and I can see my waveform, but if you adjust the level, it never locks. Never locks. So not sure yet. Need to look at the schematic and see how that trigger circuit works, see if there's anything I can test in there. I kind of suspect the level adjustment. I feel like there's probably no level threshold voltage being set to the circuit. Like the trigger's not being biased with that level adjustment. It's just got nothing, or it's grounded, or something. So I think we'll get into it and check that out and see if we can make it lock again. If we can, then I might put the money into a new set of batteries for it and get it all cleaned up. I think I'm looking at $80 worth of NiCad D-cells or nickel metal hydride D-cells, even if I wanted to give it an upgrade. But pretty significant investment for kind of a, I don't know, it's still a serviceable piece of equipment, but I mean, I don't need it, but I hate having it sit here not working either. So let's see what we can do. There's the trigger level pot. You can see it's just kind of, it's joined on a long shaft, joined right there to this pot that looks, I guess it's a dual ganged pot, because you pull on the switch there, you pull on the knob on the front, and it pops, and it switches this thing in and out. And this is just affixed by set screws, so I loosen the screws and that comes completely loose. So I'll take this nut off of here. Let's back this nut off, get this pot loose so we can see what's going on up in there. There's just too much clutter. I can't see what goes where and get good measurements of it. So let's take that loose. So I think I might have something going on here. I had set this up, opened up, and located the trigger circuit. I've got the an old scanned copy of the manual here, and it led me to this board on this side, and I was just checking a few waveforms and got it hooked up to this other scope so I could check some waveforms. And as soon as I touched the component, and in fact just this area of the board here, just put a little bit of pressure on that board, bam, locks right in. So there is something, just what I said before, poor solder joints on this board. Let's put it in normal, see if it locks in. It does. Just a little bit of pressure on that board in the general area of this trigger circuit. So I'm just gonna have to poke around and find out what needs, clearly something needs resoldering, and I sort of have the I sort of know generally where that is now. So let's see if we can make this thing trigger with let's see, get that square wave on there from this other scope that I got running. Tricky, I've only got two hands here. Trigger. Yep, it tries to trigger. There we go. So just a loose, rattly old circuit board. Let's get a look at the back side of it and see what we can make happen. There we go. I resoldered specifically the little eyelets, they call them, that connect the back side of the board to the front. It's what we call vias now, but they called it eyelets, or maybe again just a British thing, called it eyelets. But I'm not sure they're plated through. They might be little inserts that go through the board, but they're not good. And anyway, after resoldering that stuff, it Locks right in. That's good. Let's go to ×1, get a 1 kilohertz square wave on there from our other scope. It's a little noisy looking, but it locks. And trigger our negative going trigger. Yep. Keep slipping off of my test point there. Positive, negative, good. Alright, well that was good. Let's open this thing up and take a look at all these circuit boards in here, because it's quite an interesting bit of history, and we'll talk a little more about this unit and the features it has on it. And I'll order some batteries for it now that I know it's gonna be usable again. That's good. I'm not sure what I'll use it for, because it's just a 10 megahertz TV scope is what it was intended for. But you know, it's cute. It's portable. If I can get the batteries replaced, it's really handy to take with you. It's got a cover that fits over the faceplate, and a tilting stand that comes up to handle, just like the bigger scopes do. But it runs on batteries, and when I got it used, probably 20 years ago, the batteries were no good then, and they've just leaked all over the inside of the thing and ruined some stuff. But I've got it going again, looks like. So let's take a tour. Here's that trigger board. Let's just get a look at this thing before I start putting it back together. This is the board that's got the time base and external trigger input, and all the trigger controls are attached to. We'll just get a good look around here. Lots of adjustment pots, lots of transistors. Every transistor in this thing, I mean every transistor, is socketed. There. No transistors in this thing are soldered in place. They're all in sockets. Every one of them. And these capacitors are really interesting looking. That little capacitors like this one here. Lots of caps like that. There's another one up here. This one is part of the trigger circuit, so I've kind of soldered and unsoldered that one. And these are those eyelets that this machine is notoriously has a reputation for these things being poorly soldered and breaking loose. Let's get a pan of the whole board here. No ICs in this whole thing, not a one. And this is the input, the line transformer. It's got a line power comes in the back there through this transformer, through some switches for it's got a high and low range, and it also works at United States 120 volts or 240 volts for everywhere else. It's got a fuse there behind a protective holder, battery fuse and line fuse, and it's got of course a built-in battery charger for these NiCads. You can see I've got one of the wires yanked loose there because those batteries are shorted and they pull the power supply down to nothing when it's hooked up, so it just doesn't work with those in the circuit at all. Here's something interesting. Somebody came in here and made a diagram of how those batteries are wired up in there. So maybe they've been replaced before, but they need replacing again. I've had all of this apart to get in at this, you can kind of see it there, power supply board soldered direct to that transformer because the battery leaked into it and ruined the line voltage switch, line switch located on the underside of instrument. Well, it's not anymore because that switch was destroyed by the battery leakage. But there's a range switch. You can see where the line cord plugs in there. Danger, high voltage, and our CRT board is right behind that thing. External DC supply adapter input, internal battery, and a DC fuse check. I'll have to read the manual and see just what that does. That's pretty interesting. And the trace tilt correction, which doesn't seem to be working. The trace is tilted and that knob does not untilt it. Tel equipment made in England. And I said, I think I said 1972 earlier, and I think I stand by that. I have to look at the manual again. This is the left side of the instrument. There's more coils and resistors and transistors, socketed transistors, diodes, and those funny looking capacitors, lots of those, trim pots, and green two-sided board with lots of these little eyelet things. I should probably resolder every one of those I see while I'm in here before I snap it all back together. And lots of trimmer caps in the side there. Based on their proximity, I assume that's to adjust the two vertical input amps. And it's back to the front of it now. Alright, channel 1, 2.01 milliseconds. Got your trace adjustment up and down, AC DC coupling, trigger on channel 1 or 2, channel 2 selector, again coupling. Across the bottom there's the beam intensity. It also turns the machine on and off if the knob is pressed in. You're charging, it lets the batteries charge off the line power. Pull it out, it turns everything on. Focus knob there also has to do with power. If it's pulled out, you're running on line power. If it's pushed in, running on battery power. And the usual calibration socket there. Telequipment. And there's our time base down to 0.5 microseconds. And I believe it is a 10 megahertz scope. And you got your trigger mode TV, which nobody ever uses anymore, ever. AC, it's got an external trigger. You can see the BNC there for the external trigger. And here's your trigger knob. Press it in for auto, pull it out for normal. And positive or negative. Oscilloscope D32. Kind of a cool device. I think they made it for almost 20 years without making any significant changes to it. And this is an early model, somewhere in the early 70s. Here's the bottom side. And there's our pot for the trigger level. And one bank of batteries. There's our line power stuff and our transformer and the fuse, and you can see where that that S104, that's what I can see on the board right here. Oh, excuse me, S401 right here is where there used to be a little switch that you could access from under the unit with the case off, that, excuse me, with the case on, that let you switch from 120 to 240 volts. I've just hardwired it for 120 volts. Grounding lug there. And this is a little switch pot that comes all the way through there to the front. This is what turns the line power on. And same thing, there's our focus and either operating or charging switch. That board has the all the horizontal sweep and CRT drive stuff. High voltage in there. And here's the bottom of the left side, just more batteries. That big cap there, I believe, has something to do with the high voltage sweep. Let's open up the top of it and expose the CRT and see what we can see inside of there. So here's the best thing about this little unit. You loosen this screw, there's another one on the bottom just like it, and there's another one here and another one on the bottom, and these things just swing away. They're hinged in the back with other screws. Swing them out of the way, and there's enough wire on all these harnesses to let you do that, so you can open it up, make your repairs, make your adjustments, whatever you need to do. Get to the batteries. This battery cover is just screwed in right here. You just slip that off and the batteries fall out, so you can replace them. Same treatment on this side. Get to your batteries. Let's see here. Not too much of interest on the back side of these boards. Lots of wires everywhere. Lots of wiring from one side of the instrument to the other, from the board on the right to the board on the left, to all these controls and plugs back here, the batteries. Now if we loosen these screws that hold our batteries in, and that screw there, there's more on this side, I believe this whole cover will lift off and expose the CRT and some of that bottom board. I don't want to take it too far apart, but let's see what we can see inside of there. And you can see that battery holder just comes loose with a couple screws, and all the funk still in there that I gotta clean out of there. Ever ready, NiCad. What's that say? Rechargeable, sealed cell, 1.24 amp hours. Pull these two screws out of here, and this part just lifts off, revealing Allen 613130. Thank you, Allen. These little screws here, nuts and lock washers, and then these little bezel pieces just slip off like that, and then our blue graticules come away, and there's our bare tube. And I'm still trying to figure out how to raise this cover. I'm sure it's something to do with those two screws, but what else is back there? Okay, those two screws are out. Now this whole thing just opens up. I didn't really need to take that whole front bezel off, I don't guess, but interesting anyway. And it just opens up just like that. There's our CRT and the anode cap and all that shielding, and here is the business board. It looks like the flyback transformer there. Bunch of electrolytics that are hanging on still somehow after all these years. A couple of power transistors, must be the deflection transistors. And I'm looking back in there, all I see is a socket on the back of the CRT, not a board, so there's no circuitry back there, just point-to-point wiring. And there's a hardy looking transistor, C1173, and just some adjustment pots and our two front controls. And that's it. It's just so great how this thing just falls completely apart so you can work on it. I wish more stuff was built like that anymore. Okay, let's maybe solder up some of these these little eyelets. You can see some down in there already. It looks like they've already been resoldered, but hey, we're already here. We might as well clean the rest of them up, and we'll put it all back together. And there it is, reassembled. We got my tilting handle, right? And, all the bezel pieces back together, the case stuck back on there, and here's the it covers. This thing is filthy. I gotta clean this up, but that fastens right on the front of it, and the handle folds up over that. And let's see, I'll turn the line power on and device on. Let's see if it works. Still works. And I got a trace. Put that back in the middle. See, it's still kind of, well, not kinda, it really is badly sloped over to the side like that, but the turning the trace rotation knob, it doesn't do much of anything. Well, another video, but there it is. Give it a real signal instead of just a 60 hertz off my finger. There we go, locks in. Anyway, my next job for this thing, aside from the trace rotation, it looks like, is going to be replace the batteries. So if anybody knows where I can get a good deal on rechargeable D cells, be they NiCad or nickel metal hydride, 4,000 milliamps, let me know in the comments, because I've done some shopping, a little bit of shopping on my own, and I'm coming up with nothing but very expensive options. And you know, how much money do you really want to spend reviving a piece of gear like this with limited usefulness? After all, it's just so old, you know. But still neat to do. So if you know a good source for things like that, let me know. And if you enjoyed this, let me know. Give me a thumbs up, and I'll talk to you next time.